Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover sections 4, 1, 2, and 3 with exponents. So the first thing, scientific notation. When you're writing something in scientific notation, you write a number between 1 and 10. So you want to remember your n has to be between 1 and 10. So if we look at 123,000, we need to put the decimal here, because 1.2 would be a number between 1 and 10. So it's written 1.23 times 10. Now we need an exponent on it. You see where your decimal is and count how many places you need to move to where you want that decimal to be. So our decimal starting here, we move 1, 2, 3, 4, 5. So we're moving 5 units. Now you need to decide if it's a positive or a negative 5. Well, this number needs to get bigger, so we need a positive 5. So it'll stay just 5. If we wanted this number to get smaller, then it'd be a negative 5. Let's try another one. If we look at this number, we want to take this decimal and move it here. So then 3.56 is a number between 1 and 10. So it's 3.56 times 10. Now we need to find the exponent. Well, we have to move it 1, 2, 3, 4 decimal places. So we need it 4. But you still need to decide if it's positive or negative. We need to make this number smaller, so it's a negative, because this one needs to become smaller. Let's look at a couple more before we move on. So if we look at 217 million, to make it in scientific notation, we need to move the decimal here. So we have 2.17 times 10. Now we need to know what the exponent's going to be. See how many decimal places you need to move. 1, 2, 3, 4, 5, 6, 7, 8. We need to move 8 decimal places, so it's an 8. Then you need to decide if it's positive or negative. This number needs to get bigger, so it needs to be a positive 8. Let's one more. Okay, so if we have 5 hundredths, we want to move the decimal here, because if we move it here, 0.5 is not between 1 and 10. So we need to move it here. So it'll be 5 times 10 to the 1, 2, 3 to the third. And this 5 needs to get smaller, so it will be a negative 3. Let's try going the other way. If we had 2.7 times 10 to the 4th. The 4 is positive, so that means our number is getting bigger. So we're going to go 4 decimal places to the right, because this is getting bigger. 1, 2, 3, 4. 27,000. Whereas if it was a negative, this number needs to get smaller, so we're going to go this way so it's smaller. 1, 2, 3, 4. So we would have that. So if we look at this number, your book uses a dot. I'm so used to using an X. But whether it's an X or a dot, it's the same thing. It means multiply. So we have 21 times 10 to the 8th. We want to write it in scientific notation. So we need to move the decimal place over 1 so that it's 2.1. We are taking away a 10 position. So we need to add a 10's position. So it's 10 to the 9th. So here we're taking away 1. We need to add it. This one, we want to add a position because we're going from 9/10 to 9. We're adding a 10, so we need to subtract it. So we added it here. You could think of taking one of these and multiplying it, so we have to subtract it out. Some exponential rules. When you're multiplying, you add the exponents. So if you have the same base, you add the exponents. When you're dividing and it's the same base, you subtract m minus n, top minus bottom. An exponent to an exponent, you multiply. So it would be x to the mn. Anything to the 0 power is 1. So 10 to the 0, 1,000 to the 0, a, b, c, in parentheses to the 0 is 1. All of those. Anything to the 0 power is 1. A negative a to the n. If n is even number, 2, 4, 6, 8, when you square that, you get the positive, so it's a. Whereas if it's odd, it's negative a. When you have all multiplication, you can distribute your m. So it's x to the m, y to the m. But that only works when it's multiplication. Same thing with division. X to the m, y to the m. You cannot use addition or subtraction with that rule. The next rule, when you have a negative exponent, if you move it to the denominator, it makes it positive. Or if it's in the bottom negative and you move it up, it makes it positive. So anytime you move up or down, it changes the sign on the exponent. When you have a fraction, if we distributed, they'd both be a -1. So if we flip it, it makes it a positive. So if you have a negative on a fraction, you can flip the fraction and make the exponent positive. The last one is a fraction. A radical is a fractional exponent. So the square root would be 1/2. If we had a cubed root, that would be 1/3. If we had x to the cubed root of x squared, that would be x to the 2/3. So the radical is the fraction, the denominator of the fractional exponent. If we had x cubed, the square root of x cubed, then that would be x to the 3/2. So whatever this root is, it's the denominator of the exponent. So if we had, not x, let's put a number in there. 8 to the 4th, and we wanted the cubed root of it. well, 8 times 8 times 8 times 8 is pretty large. Notice we could do the cubed root first and then take it to the fourth. The cubed root of 8 is 2. 2 to the fourth is 16. But you could also have rewritten that to the 4/3, so then you do the radical first. Okay, let's try some of the rules. So this one's an exponent to an exponent. An exponent to an exponent you multiply, so that's x to the 12th. This one you have the same base. When the bases are the same, you add them. 3 plus 4 is x to the 7th. Move this line out of the way. When we're dividing, you subtract top minus bottom. So it would be x to the 1st. When it's a 1, you don't have to show it. This one, top minus bottom, 5 minus 7 is x to the -2. You shouldn't keep negative exponents, so we need to move it to the denominator, x squared, 1 over x squared. Okay, this one, I'm going to combine the top first. 3 plus 7. If you want the bottom at the same time, minus 4. So the top we add, the bottom we subtract. 10, 6, x to the 6th. Order of operation, you do exponents first. So we would need to do this first. Exponent to an exponent is multiplied. 4 times 3 is 12. And then here, same base, add the exponents. 2 plus 12, or x to the 14. Next one, remember when there's no value, you can think of this as a 1. And then we can multiply. This is multiplication, so we can distribute the exponents. X to the 3 times 4 is 12. And here 4 times 1 is 4. And then we can combine those and get 16. We could have also done this one first. If we did inside first, 3 plus 1 would be x to the 4th. And then to the 4th, and 4 times 4 is x to the 16th. So either way, you're getting the same answer. This one. Okay. The squared. 3 squared is 9. And then here, exponent to an exponent, we multiply. So we have 9x to the 10th. This one, plus 2. When we multiply these bases, we add the exponents. 6 and 4 is 10. Adding and subtracting, remember you have to have like terms. And these are both like terms. So when we combine them, 9 and 2 is 11x to the 10th. Here it's squared. 2 squared is 4. Exponent to an exponent is multiplied. 5 squared is 25. And 4 times 2 is y to the 8th. This one, we're multiplying all of these. Remember, when you're multiplying, you add your exponents. And you can just add them all together. So we have x cubed plus 1 plus 2. 3, 1, and 2. And then the y's, 1 plus 1 plus 3. So we have x to the 6th, y to the 3, 4, 5. On this one, we have nothing to combine the 3 with. Combining these, we're dividing, so we subtract the exponent. So we have 5 minus 2, y to the 10 minus 3. So it's 3x cubed, y to the 7th. 4 cubed, 4 and 4 is 16, times 4 is 64. X, exponent to an exponent we multiply, so x to the 9th, y to the 2 times 3 is 6. Okay, this one's negative, so it's up to you if you want to move it to the denominator first or multiply these through first. If we multiply them first, we have x, negative 3 times 3 is a negative 9, y, negative 3 times 2 is a negative 6. But then we need to move both of them to the denominator to make them positive. So we have x to the 9th, y to the 6th. This one, I would probably flip the fraction first to make my negative positive. If I flip it, I have y over x cubed. That makes this a positive 2. And then distributing, exponent to an exponent's multiplied, so we have y squared over x to the 6th. And this one, top minus bottom, so we have 2 minus 1, and y to the 1 minus a negative 2. So we have x to the 1st and y to the 3rd. This one's different. They want you to keep the same base. So if we add these two together, this is one of these and this is one of these. So we have 2 times 2 to the 5th. Now 2 times 2 to the 5th, they're the same base. We can add the exponents. So this is actually 2 to the 6th plus 2 to the 6th plus 2 to the negative 3. Again, there's 2 of them, so that would be 2 times 2 to the 6th plus 2 to the negative 3. 2 and 2, add the exponents, and you get 2 to the 7th plus 2 to the negative 3. The other part, as long as we're going to keep, oh, we need to move the 2 to the denominator. Let's do that right here. Because this is a negative exponent, it would be 1 over 2 cubed. But they want you to keep the 2 as a base, so you wouldn't go any further and multiply it out. Okay, next one. The square root of 9 is 3. Now when you're taking out values, this is a square root. You're dividing the exponent in half. Oops, I'm taking it out. So I have 3x to the 5th over square root of 25 is 5. And then you divide your exponents by 2. So it'd be x squared y to the 4th. When you have an odd value, so when it's even, you're just dividing it in half. But what about when it's odd? Well, we know that x to the 5th is x to the 4th times x. The even part comes out and the 1 stays in there. So this will come out dividing it by 2 and get x squared square root of x. So if we had the square root of x to the 15th, we can rewrite that as the square root of x to the 14th times x. This one will stay under, this one gets divided by 2. X to the 7th square root of x. Right here. This one, I think I would flip it first and make this positive and then just simplify what we have inside. So we flip the whole fraction because this negative is on all of it. So we have 3xy over 2x squared y to the negative 3. And then it's top minus bottom. The 3/2 is going to stay because it doesn't simplify. And we have x to the 1 minus 2 and y to the 1 minus a negative 3. 3 over 2. This is going to be a negative 1, so I'll move it to the denominator to make it a positive 1. And this is y to the 4th, so it stays on top. I'm running out of, let me write these on another paper. So this, I would multiply these first because notice this whole thing is on this one and then this is on that. So a negative, we can multiply these exponents first. Negative 3 times a negative 5 is a positive 15. Then this is all multiplication. We can multiply it out. So we have 3 to the 15th, x to the 3 times 15 or 45, y to the negative 30, and z, so 1 times 15 is 15. This is negative, so we need to move it to the denominator. And make it positive. The next one, you need to simplify them before you can combine them. Just like x's have to be the same, radicals have to be the same to be like terms and combine. So 3 square root, there's a perfect square in 8, it's 4. So we can pull the 4 out. Kind of like when we pulled the x out, we left the part that wouldn't simplify. The same thing here. 50 has a perfect square, 25 times 2 is 50. So the square root of 4 is 2. And the square root of 25 is 5. And these get multiplied. This step could be skipped. When you pull it out, just multiply it. But the square root of 4 was 2, and the square root of 25 was 5. So I have 6 radical 2 plus 10 radical 2. Same base, add the values in front. 6 plus 10 is 16 radical 2. There was one more I wanted to show you. This is not equal to x squared plus y squared. It's a really common mistake. If you're taking a quantity squared, then that's x plus y times x plus y. You need to FOIL it. And if we FOIL this, we have x squared plus xy plus xy plus y squared. These aren't canceling. Those are like terms that we add. X squared plus 2xy plus y squared. So this is not this. So you want to be careful of that. And that's everything for those two sections.